Right, before I just say words, did all of you receive the geometry reasons list that Watobe should have emailed you? You can just say yes or no in the chat. Oh, wonderful. Okay, so what I did was I put together all of the reasons that we've covered in our classes. Some of you might have done a couple other reasons. It really depends on where you're at. And some of you might have spoken about things like congruency and similarity and triangles, but we will speak about that next year in grade 9. But basically what I've done for you is I've put together a whole geometry list. And my advice is you don't have to print it out or anything like that, but use it as a starting point to start learning your reasons and have it as like an information sheet that you can get. Luolo, you should have gotten it from Watobe, so try and maybe contact them and see if you can get it, because I did send it out last week for them to email to you. So it should be there, but get in touch with someone from Watobe and you should be able to get it, okay? But all of the reasons are here in this lesson. Oh, Bridget, there we go. Got it on WhatsApp. Maybe try that. But all of the reasons are here. So as we go along, you're welcome to take screenshots as we go. Sorry, got a frog in my throat. Okay, so guys, basically we had 3 major groups of geometry reasons that we spoke about here in Watobe. So we spoke about straight line geometry, we spoke about parallel lines, and we spoke about triangles. Those are the 3 sort of groups of geometry reasons that we have learned so far. And so what we're going to do today is essentially just practice those reasons and make sure that we understand them. So if we start with our straight line geometry reasons, there were 3 that we needed to know. So these reasons are, firstly, angles around a point. The fact that all angles, doesn't matter how many they are, as long as they are around a central point, they add up to 360 degrees. Now, everything in the block here is the geometry reason that we have to give when we've made a statement. So remember, geometry, you always have to give a reason for a statement. These are my reasons in the blocks. Okay. So if you're going to use angles around a point, you use exactly that reason, angles around a point. The next reason that we spoke about was angles on a straight line. The fact that any angles, and again, it can be 2, 3, 7, whatever, as long as they're on one continuous straight line, they add up to 180 degrees. And so our reason there is just angles on a straight line. And finally, the last straight line geometry reason that we learned was the fact that vertically opposite angles are equal. And so basically what that means is when you have this sort of like cross shape, the angles opposite each other at the intersection between the 2 lines are equal in size. So the 2 circle angles, AED and CEB, are equal to each other, which is what that statement says. Let's maybe do this a bit better. So those are the 2 circle angles, and the fact that AEC and DEB are equal to each other. So vertically opposite angles are equal. Again, we have a reason that we use vert op angles equal. Now, again, I just want to make clear that your reasons that you learned in school might look a little bit different to my reasons here. And you can obviously like edit them as you go along. Use the reasons that you're comfortable with, but all of the reasons that I've given here are perfectly fine to use as well. But if you want to use the ones that you've been given at school, that is obviously absolutely fine. Sorry, guys. Okay, so those are the 3 sort of basic straight line geometry reasons. So we're going to have a look at some questions and try and use these reasons here. So we've got 3 questions here. Maybe let's not jump the gun. Let's have a look at question A first. So who wants to, you can put it in the chat, you can raise your hand, you can, whatever you want to do. Who wants to try and tell me what reason I could potentially use to answer question A? Now, the goal in question A is to work out the size of angle X. I do apologize, I didn't put reasons, I didn't put actual questions there. How can I do this? Voltari, what do you think?
Ma'am, I think we should use angles on a straight line.
Good. And what should angles on a straight line add up to?
180 degrees.
Fantastic. Do you want to give it a try?
No, thank you, ma'am.
Okay, cool. So that is 100% correct. We know that these two angles, it's a bit weird, on the straight line need to add up to 180 degrees. And so because we know what reason we're going to start with, we can start setting up an equation. So we know that the angle 3x plus 30, which is the angle on the left there, plus the 42-degree angle must equal 180 degrees. Now I've made a statement here, so I have to give a reason. And my reason would be angles on a straight line. Now you are welcome to abbreviate straight to STR. You can obviously write it out as well, it really doesn't matter, but obviously to try and save some time as you're working through these questions, we do allow you to abbreviate things. Right, and so what we now have is an equation. So Lungile, do you want to give it a try? Okay, no problem. Okay, cool. So let's do it. We've got an equation. We're going to solve the equation. Now, we spoke about equations on Monday, so we hopefully have this somewhat fresh in our heads. The first thing I want to do is get this 3x alone on the left. So I'm going to keep the 3x there. But what I need to now do is I need to go and subtract 30 degrees. And okay, let's maybe not do it in one step. Let's first, you can do it in one step, but let's not confuse the situation. Let's first neaten up the left and add our like terms together. So 30 plus 42 degrees gives us 72 degrees. And all I've done is I've taken it down from two constants to one constant on the left. You don't have to do that. It just makes life a little bit easier. Now I'm going to use my inverse operations and say, okay, let me subtract 72 on both sides. I need to subtract because it is the opposite of what the original operation was, which was plus. And so I've got 3x is equal to 180 minus 72. Right, you just do that on your calculator. I want to say it's 108 degrees, but my mental maths today is a little bit dodgy. 108 degrees. We subtract the 2 and we get 3x is equal to 108 degrees. Okay, does anyone maybe want to tell me what my next step should be? How am I going to get x alone here? What should I do? You can raise your hand or you can put it in the chat. What should my next step be? Lungile?
Hi, ma'am.
Hi.
You must divide
By what?
by 3.
Excellent, well done. So guys, we don't want this 3 in front of the x. We just want x alone, which means I need to divide both of those sides by 3. And so I end up with 3x divided by 3 and 108 divided by 3. Lungile, can you tell me what 108 divided by 3 is?
Yeah.
You don't have to.
No, yeah.
Okay, right. So guys, 108 divided by 3 is, I'm going to take your word on it, Buntle, 36 degrees. And so x is equal to 36 degrees here. Now remember, that was our goal. We wanted to solve for x. We can always go and double check ourselves, and this is quite similar to equations, by taking our answer for x that we got and substitute it back into the angle that had the x in it. So if I take that and substitute it back in, 3 times 36 is 108 plus 30 is 138. And then we've got 42 degrees. And if we add 138 and 42, we get 180, which is what we know those two angles on a straight line should add up to. And so through using our geometry reasons, we have gotten the correct value of x. Okay, so a lot of these steps here you don't necessarily have to show. It very much depends on how comfortable you are with solving equations and essentially simplifying to solve for x. if you don't feel 100% comfortable, rather show more working out than maybe is necessary, just so that you're not making unnecessary mistakes. But I would be fine with you sort of going from step 1 to step 3 to your final answer. But again, show as much working out as you need to in order to feel comfortable with your answers. Right, I'll leave it up there for a second if you want to take a screenshot, and then we'll have a look at our second question here. Okay, I'm assuming we all have screenshots. Let's have a look at question B. So again, take a look. We've got two angles, 3x minus 12 and 108 degrees. Can someone give me a suggestion? You can either raise your hand, you can put it on the chat. What geometric reason can I use to solve for x here? Our QA, what do you think? Our QA, you there?
I also can't hear our QA. Our QA, it could be that you're not connected to audio. No, you are connected to audio. That's why we can unmute you. I'm not quite sure. Maybe your speaker. Are you with headphones? If you can hear us, can you please remove your headphones so you can talk to us? Maybe we can hear something.
Ma'am?
There we go.
Oh, ma'am, it's vertically opposite angles.
Excellent, well done. So we can use vertically opposite angles. Now, our QA, what do we know about vertically opposite angles? What should they be?
They should be equal.
Exactly. So do you want to try and set up something here to help us solve for x? You don't have to. I'm putting you on the spot. You can say no.
No, ma'am.
Okay, but exactly as our QA said, guys, we have to use vertically opposite angles. Now, what that means is that we know that this angle, 3x minus 12, must be equal to 108 degrees. And because of that, we can set up an equation for ourselves. So we know that 3x minus 12 degrees must be equal to 108. And that is because, exactly as our QA said, vertically opposite angles are equal. Okay, so remember, I've made a statement, I give a reason. Now I can solve my equation. So the first thing I'm going to do is I'm going to add 12 on both sides using those inverse operations, because this is an equation. So we solve like a normal equation, and we get 3x is equal to 120 degrees. And then very similarly to the first question, we want x alone. So we're going to divide both sides by 3. And someone quickly pop it in the chat for me. What is 120 divided by 3? Excellent. So x is equal to 40 degrees. Again, I can go and check myself if I want to. If I go and substitute 40 in place of this x over here, 3 times 40 is 120. 120 minus 12 is 108. Okay, that obviously looks weird because I chose to write it in a highlighter. And we can then clearly see that 108 is equal to 108. And so my vertically opposite angles are equal to each other. Nice, guys. Well done. Again, I'll leave this up if you want to take a screenshot. And then we're going to have a look at our third one.
We are nailing this, my pebs. Y'all did well.
Okay. Right. Whoops, sorry. So here's question C. Again, what should we do? What geometric reason can we use here? I'm asking. Someone tell me what they think.
Remember, you can unmute and talk, my bibs.
Oh, that was a weird noise.
Okay, I think Bukhari is answering. Bukhari, do you want to say something?
Yes, ma'am. Ma'am, I think it's angles around a point.
Awesome, well done. Okay, so guys, what we notice here is I'm just clicking things, sorry, is the fact that all of these angles are formed from a central point. And because there is one central point that all of these angles go around, we have got angles around a point. And we know that all of those angles around the point is a revolution, which is 360 degrees. And because I know that fact, I can now set up an equation for myself. Does anyone want to try set up an equation for me? Now that we know that all of those angles together should give us 360. Lungile, give it a go.
Hi, ma'am.
Hi, sorry.
Ma'am, I'm not sure name, but I think you say 2x minus 10 plus 53 plus 62 plus 85 equals to 360 degrees.
Excellent. And what's your reason?
Angles around the point.
Wonderful. Well done. Okay, again, guys, we can abbreviate point. We don't have to write out point. PT is fine. You can write out point if you want to. But Lungile has beautifully set up our equation for us. We add all 4 of those angles together and we get 360 degrees. Now, again, what I notice is the fact that the -10, the 53, the 62, and the 85, they're all like terms. They're all constants. So let's just add them together to neaten up the left-hand side. So 2x is equal to 190. So plus 190. So if I add -10 plus 53 plus 62 plus 85, I get 190. Yes, 190, which is equal to 360 degrees. From there, again, using my inverse operations, I first want to subtract 190 degrees on both sides because I don't want that 190 there on the left. And so when I say 360 minus 190, I get 270. So 2x is equal to 270. Who wants to tell me what my next step needs to be? Raise your hand or you can pop it in the chat. What should my next step be to solve for x? Bontle, what should I do?
Ma'am, I see 270 divided by 2 and 2x divided by 2.
Fantastic. We want to divide both sides by 2. And what is 270 divided by 2?
135.
Excellent. Degrees. Well done. And yes, very importantly, degrees. So x is equal to 135 degrees. And so we have solved for x there. Okay, so guys, those 3 examples sort of go over all of our straight line geometry reasons. Angles on a straight line, vertically opposite angles, and angles around a point. And again, being comfortable with all of these reasons and being able to use them all is very, very important. Again, I'm just going to wait there for a screenshot if you want to take one, and then we will do our brain break.
Time flies and my people are nailing this. Y'all, I'm sure you're going to get marks in math.
Okay, I'm hoping everyone's got their screenshots. Oy, oy, oy. Sorry, I just put it right at the end. So okay. Nice, Bontley. I'm glad you get excited for them. So again, guys, we have got a guess the phrase situation going on here. I hope you enjoy my cow joke as well. Why do cows have hooves instead of feet? Because they lack toes. I thought it was quite funny. So
It is funny. I'm kidding.
we have got 5 phrases here that I want you to try and guess what they're saying. Oh, Aokiwe's hand already up. Aokiwe, which one do you think? Aokiwe, are you there?
Misunderstanding.
Well done. Okay, so this first one is misunderstanding because miss is understanding. Well done. Very nice. We got any others for us?
Ma'am, number 4.
Yeah?
It's 4-wheel drive.
Well done. 4-wheel drive. Excellent. Awekiwe. Let's see. Some other people have their hands up. So let's see. Masejo, what do you think? Which one?
And number 2 is weather.
Is which one? Sorry.
Number 2 is weather.
Okay, what is wrong with that weather though?
There's an A
Is
that
it-
is missing.
Yeah. So do you agree it's spelled badly?
Yes, ma'am.
So it's bad weather. That's a very long B. Oh, whatever. Right, well done. Bad weather, because it's spelt incorrectly. Bridget, which one?
Ma'am, number 3 is too little, too late.
Well done. Too little. You guys are on fire tonight. Well done. Nice. Anyone got number 5? Masejo, I still see your hand up. Do you have it? Oh, we're stuck on. Oh, well done, Zembo. Short notice because it's missing. It's similar to the weather one. It's missing an E, so it's shorter letter. So short notice. Well done, guys. You got that quicker than I would have gotten it. Very nice. Okay. I don't know if anyone wants to take screenshots. Well done on getting those. That was very impressive. Like I say, I would not be able to get them as quickly as you did. Okay, so let's go back to some geometry. Right, so we've done our straight line reasons. We've looked at some questions there. And so what we're going to have a look at now are our parallel line reasons. So this is not all going to fit on one screen because otherwise it's going to be way too small. So we're going to go through our parallel line reasons and then we will have a look at some questions. So for our parallel line reasons, there are 3, and you can sort of think of it how you want. I always remember fun. Those are sort of the shapes that the parallel lines make. And so I remember I'm looking for an F shape, a U shape, and an N shape, and that should then give me equal angles or supplementary angles between parallel lines. Now, a couple things. These little arrows on lines means that those lines are parallel. And so we have to have those arrows on those lines telling us that the lines are parallel in order to use these reasons. If they aren't there, it means that the lines aren't necessarily parallel, and so we can't use the reason. Okay, so the first one is corresponding angles. Now, corresponding angles is the F shape, so we can see our F shape over here. And basically what corresponding angle says to us is the 2 angles in sort of like the corners of the F are equal to each other. So those two angles are equal, and hence they are corresponding. Now, very importantly, when you give your reason, you will not only say corresponding angles, but you will also state which lines are parallel. This is very important because sometimes we have more than one pair of parallel lines in a diagram. And so we need to state which ones we're working with so that it's very clear which corresponding angles we are referring to. Okay, so that's the F shape, that's corresponding angles. They are equal to each other. We then have the U shape, which are our co-interior angles, sorry. And this is a little bit different in that the co-interior angles are not equal to each other, but rather they add up to 180 degrees. So when I add the two angles at sort of like the bottom of my U shape, they will give me 180 degrees. These are co-interior angles. And again, I have to state which lines are parallel when I give my reason. Right, and then finally, we have our alternate angles. The alternate angles are the N shape. The sort of angles in the corners of the N are equal to each other. And again, it's alternate angles, and we always state which lines are parallel that we are working with. So those are my three parallel line reasons. I don't know how small this needs to get in order for us to get all of them. That seems quite small. But there you go, just in case you want to take a screenshot of all of those reasons together. But we're going to have a look at some examples of how we use these reasons. Now, very importantly, as you start to learn more and more reasons, it does mean that there's often multiple different ways to answer a question, which is fine. As long as the reasons are correct for the given diagram, it doesn't matter that you might have done it slightly differently. Okay, but let's have a look at our first question here. So here we've got question A. We've got two parallel lines. Now remember, I know that these are parallel because they've got the arrows on them. So those are my two parallel lines. And I've got an angle of 5x and 125, and I want to get the value of x. So does anyone want to give me a suggestion of how or which reason I can use to find x? Okay. Which of my parallel reasons could I use here? Tari, what do you think?
Ma'am, I think we should use corresponding.
Excellent, well done, because we've got an F shape, right?
Yes, ma'am.
Good. So guys, because we've got this like upside down backwards F shape, we know that we're working with corresponding angles. And so we know that the angle 5x should be equal to the angle 125. Now, I can't just do that without a reason. So I put in my reason, corresponding angles. I forgot how to spell there. And I do have to state which lines are parallel. Now, because I haven't given you labels like I did here, it doesn't really matter. All we state is then that we have parallel lines. And remember, the symbol for parallel are two like vertical or diagonal stripes. Right, now I need to solve for x. So, Voltari, do you want to, English. How can I now go and solve for x? What should I do?
Ma'am, I think we should divide both of them by 5.
Excellent. So we're going to divide both sides by 5. So 5x divided by 5 and 125 divided by 5. And when I divide 125 by 5, I get 25 degrees. And so in this question, x is equal to 25 degrees. Oh, golly. My one desk chair like slides out. I don't really understand why, but anyways, the other one doesn't do it. Okay. If you want to take a screenshot, do. But because we had an F shape, and the F doesn't have to be like a normal looking F. It can be upside down, it can be flat, it can be very squished. As long as there's sort of an F, we can use corresponding. Okay, so let's have a look then at question B. Who wants to tell me which reason we can use to find the sides of x in question B? Again, I've got parallel lines here. of, or these rather, are my parallel lines. I don't have labels, doesn't matter, but those are my parallel lines. So which reason can I use to solve for x here? Lungile, what do you think?
Ma'am, I think it's corresponding
Okay, why corresponding?
because there is an F.
Okay. Okay, cool. So you definitely can use corresponding angles here. We just need to be careful in that the F shape that we're looking at would be sort of this F shape. And so we would be, we would be saying this right angle is equal to this right angle, which is fine in this case. I'll come to that in a second. So good, Lungile, we could use corresponding. Anyone got any other suggestions? Remember, I said there's often different ways that we can do it. Bontle, what do you think?
Ma'am, I think co-interior.
Oh, yeah. Guys, you like are way more on it than I was. It's amazing how when you just think one thing, you can. No, that was terrible English. Never mind. Right, co-interior is the U shape. So that yellow bit there is the U shape, which is fine. We know that this angle plus this angle must equal to 180. Any other suggestions? Voltaria, which do you think?
Ma'am, alternative angles.
Right, that's where I would have gone. Okay,
Yep.
so alternate angles is the Z shape. We know that this angle must be equal to this angle. And because clearly my brain was working on a much higher level than it is today when I set this up, all three are absolutely fine. And because we've got an opportunity to do all three, I'm going to show you all three so that you can see that there are different ways to answer a question, especially in geometry. Okay, so let's start with the very first one which we got, which was corresponding. So what I'm going to do is I'm just going to take off all of my scribbles and start with that. So the corresponding, guys, is this red F shape that we have there. So the red F shape is essentially saying to me that this angle, let's just call this angle A for now, must be equal to angle B. Now the problem is, as it stands, I didn't give you what angle B is. And actually, let's not do this. Let's do this so much better. I'm going to add some labels. A, B, C, D, E, F. Okay, so we've got some labels here. So what this means is that angle CEH, so this angle over here, must be equal to angle AFH, this angle up here. That's because of my F. Now, I don't know what this angle CEH is, but I can find it because I've got that geometry reason that tells me that vertically opposite angles are equal. So option 1 for this answer is to say that angle CEH, and remember, when I've got an angle with 3 letters, the little hat always goes on the letter in the middle that represents where that sort of vertex or corner of the angle is. So we know CEH is equal to 70 degrees because we know that vertically opposite angles are equal. And now because of that, I know that angle CEH, which is that bottom one over here with the sort of now very big circle, must be equal to angle 3x plus 10 because of my F shape, because they are corresponding angles. Now I've added labels to these lines. So my 2 parallel lines are AB parallel to CD, which I always add in my reason. And now I know that CEH is 70. And so I know that 70 is equal to 3x plus 10. And I can now start to solve for x. So I would subtract 10 on both sides, leaving me with 70 minus 10 is equal to 3x, which means that 60 is equal to 3x, which therefore means that x is equal to 20 degrees. If you write it in the sort of other order, so x equals 20 or 20 equals x, it's exactly the same thing. Doesn't matter which order you write it in, as long as you get x alone, you have found your solution. Okay, so that's option 1, using corresponding angles. Option 2, we said, was co-interior angles. Whoops. I'm going to get there in the end. Right, so co-interior angles is now, I'm going to just start making a mess, so let's just leave that. Co-interior angles is then the U shape. So the U shape we had was over here. Now again, I need to know what this angle CEF is, but I can easily work that out because I can use angles on a straight line. So using angles on a straight line with the 70, and this is now option 2, we know that angle CEF, or you can say CEG, doesn't really matter, is equal to 180 minus 70 degrees, because angles on a straight line must equal to 180. And so I know that angle CEF is equal to 110 degrees. So this angle in here is 110. And now that I have that, I can make the statement that 3x plus 10 plus 110 degrees must be equal to 180, because those angles are co-interior angles. And again, I state my parallel lines AB parallel to CD. Once I've done that, let me just move this down so we've got some space. Once I've done that, I can now go and solve my equation. So I'm going to first add the 10 and 110 just to simplify it a bit. So I've got 3x plus 120 equals 180. I'm going to subtract 120 on both sides, which gives me 60. Panic. And if you have a look at this step is exactly the same as what we got over there in the last one. So it's going to give me exactly the same answer of x is equal to 20. And this is again why I say we can often do this in more than one way. All right, so that's option 2. I feel like I've been talking for a long time. Does anyone want to try option 3 that said to us these are alternate angles? So I feel like we're now tired of my voice. If no one wants to try, can someone at least tell me what do we know about alternate angles? Are they equal? Do they add to 180 degrees? Do they add to 360 degrees? What do we know about them? Bontle?
Hi, ma'am. Alternating angles are equal.
Okay, cool. So do you want to try set up an equation for me here?
No, ma'am.
Okay, fair enough.
I haven't thought of that yet.
Okay, so Bontle has told us that these angles are equal, which means that 3x plus 10 must be equal to 70 degrees. And whoops, this is exactly for the reason given, alternate angles. Again, we state which lines are parallel. AB is parallel to CD, but now we can go and solve our equation. So I'm going to subtract 10 on both sides. And once again, we see that this next step is exactly the same as what I had in option 1 and then in option 2. So I'm going to end up with exactly the same answer. Now you can see that option 3 is definitely the shorter way to do it. However, that doesn't mean that the other 2 are wrong. And so there's 3 different ways to get exactly the same answer. And whichever one you see, absolutely fine. Okay, so I'll make that a tad small in case you want to get all of them, all of them together. Right, I'm actually going to skip this one just that we can at least chat about the four triangle reasons. So we spoke about 4 different triangle reasons in our geometry section. Now, I had words in my head and now they've all just disappeared. When working with these reasons, again, make sure that once you've made your statement, you give your reason, but these apply specifically to triangles. It can be any triangle, but it has to be a triangle. Right, so what we know, or rather the first reason that we spoke about, is the fact that if I add all 3 angles inside a triangle, I'm going to get 180 degrees. And my reason there was sum of angles in a triangle. The next reason that we had a look at, which was, I'm just going to make this a tad bigger so that we can actually see what's going on. The next reason that we had a look at was the fact that the angle outside a triangle, so the exterior angle of a triangle, is equal to the sum of the 2 opposite interior angles. So if I add the 2 interior angles that are opposite the exterior angle together, I will get the angle outside the triangle. And our reason there was exterior angles of a triangle. So those were the first 2 that we did. Those are sort of probably the ones that you're most comfortable with. But we did speak about 2 other triangle reasons. Now, the first one, again, is the one you'll probably use more often. This reason says that if you are given 2 equal sides in a triangle, so given 2 equal sides, then what you know is that the angles opposite those equal sides are equal to each other. And so this is saying that angles opposite equal sides are equal. We can also make the converse statement in that if I give you that the angles are equal to each other, you can then go and state that the opposite sides are equal to each other. And that would then be sides of equal angles. Now, the second one we don't use that much at this current point in time. You are eventually going to start using it quite often, so it is an important one to know. But essentially, if you have 2 equal sides, the angles opposite them are equal, and then on the converse, if I give you the equal angles, the sides opposite them are equal. Right, so let's try a question before we sort of end off, and I think I'm going to pick question B. So question B, we've got X and Y that we want to find. I've given you the small little angle at the bottom there of 21. And I've given you the exterior angle outside there of 58 degrees. So you can start anywhere. Does anyone want to give me a suggestion for how I can find X or Y? Does anyone, sorry, let me do this. Sorry, guys, in case you want to screenshot those reasons, there you go. And you can still see question B, so have a think, how can I find X or Y? You can start wherever you want. Okay, who's going to give me a suggestion? Claire, which one?
Ma'am, I think exterior angles of a triangle.
For which angle, X or Y?
Y.
Excellent, well done. Okay, so guys, and it doesn't matter that we start with Y, as long as you get X and Y in the end, we really don't care. We've got a triangle here, and we can see that this 58 is an exterior angle because it's created from an extension of one side between another side. So that therefore means that 58 is equal to Y plus 21. It's equal to the sum of the 2 opposite interior angles. And so what that means is I can set up an equation. Y plus 21 degrees is equal to 58 because of exterior angles of a triangle. And so now I can solve for Y. That means I will subtract 21 on both sides, which is, oh golly, sorry. Y is equal to 37 degrees. So now I know that that is 37 degrees. Anyone want to give me a suggestion of how I can find X? There are a couple different ways you could potentially do it. Bonke, I see your hand still up. Do you want to tell me?
Ma'am, I think sum of angles in a triangle.
Perfect. We can use sum of angles in a triangle. So now I know that x plus the angle 37 that I just found plus 21 degrees must equal 180 degrees because of sum of angles in triangle. So x plus 37 plus 21 we know gives us 58 is equal to 180. And if we now subtract 58 on both sides, we get 180 minus 58, which is, I want to say 122, but let me double check myself, 122. Another way that you could have found x is you could have used angles on a straight line with 58 and x. But again, you've got the answer. And so here we've looked at sum of angles in a triangle, exterior angle of a triangle. You could have used angles on a straight line. And so we've got an x and y. Alrighty, guys, but that is essentially all of your geometry reasons that you need to know.